living up to the low expectation of mathematicians giving talks. Usually they're not the most interesting people. So I got my PhD a few years ago, and then I worked as a postdoc before I transitioned into the industry. The road was rough. I don't want to be giving you a false impression that the transition was easy, so that's why I'm here. I really hope that you'll have an easier time than I had. Prepare yourself for the transition. Start early, and I'm sure other panelists have the experience to share.
Hi, my name is Bernard. I have a fairly similar story. I finished my PhD a couple of years ago, did a postdoc. I got an offer a postdoc in San Diego, and I was like, well, San Diego, you got to go. So after that, in my last year, I was looking for a job like I think everybody else here. And yeah, I actually got into this whole field because there was a competition. I joined it. I didn't know anything about Python. I learned Python in a week, and the way you go, and after that I took some courses and then kind of became a data scientist. But it's a very condensed version. There's a lot of other things that happen in between that. So if you have any questions, you can ask me about the transition or the work I'm doing right now. So.
Hi, my name is Roger, and as stated, I run my own company. What I did was when I graduated from Caltech, I decided I didn't want to live in the States anymore. I wanted to live back in Vancouver. And at the time, I was working for Google and said, well, you know, there's nothing quite like that here in Vancouver, so I'll just start my own company. And you don't just start your own company. I had an enormous amount of support from my family. In particular, my brother was a consultant in the software industry and really gave me a huge leg up on what to expect and the kinds of problems that I should expect to be able to solve. In any case, this was almost 10 years ago, and I've maintained a relationship with UBC, and at the same time, I've just about never advertised myself and have been very, very lucky, I think, in continuing to meet new people at this really great time in history when we have, you know, such interest in data science and large people know that mathematics is very useful for them, and you all have a massive advantage in the workplace because no one wants to teach you mathematics. But if you're able to program even just a little bit, they're willing to take you on, and that's what's been happening to me time and time again as I've gathered new clients over the last, as I say, roughly decade.
Great. Hi, everyone. My name is Zach. I think I'm the odd one out here. I don't have a long track record of academia. But we heard you hire them. That's right, we do hire them. That's exactly right. So, so for me, after graduating, I went directly into the industry. My experience with hands-on with data science field has been mostly around ETL and processing data from getting this data from this system into that system, analyzing it, trying to really make sense out of what that means. You could probably describe me as your typical engineer. Coming out of school, 9 to 5 job. There is no such thing as 9 to 5 job, but coded for a couple of years, moved into an architecture role, moved into a management role. I've been with AWS or Amazon for about 5.5 years now. It's absolutely amazing. Love it. A lot of what Roger was saying around math being an incredible, having a mathematical background, giving you a tremendous leg up in the industry is so true. And some of the core problems that we're working on are things like how do you shard data across multiple clusters? How do you shard data and have the most amount of density on our servers? We are one of the groups that we work with is our simple storage service, and the number of servers that we have are close to hundreds of thousands for just one service. So, and we're trying to figure out how to pack as much data into them, and it's not an easy problem. It requires a tremendous amount of brain power and a tremendous amount of thinking. So, everything you're learning now is absolutely applicable to the real world, and that's going to give you a tremendous amount of leg up. So happy to talk about that. Anyways, I won't bore you guys too much more. If I'm sure we'll get a chance. I'll bore you guys later. So I'll pass it on.
Hi guys, I'm Megan. Yeah, I think I'm similar to you where I don't have quite the same length of academia. I did my undergrad in mathematics, so I have a math degree to start. Then I came out here, I went to SFU, I did my master's in stats there. I actually didn't finish my master's in stats, I started working instead, so that's what I did instead. So I actually worked at Deloitte for a couple of years doing consulting on their advanced analytics team. And then I actually came and worked here at Mobify for a few years and was working with Boris over there, doing lots of data science here. And then now I'm at a place called Absolute Software, working on a team doing user behavior modeling, trying to figure out all kinds of fun stuff about how people use computers. So it's lots of fun. So yeah, if you have tons of questions for me, please let me know. That would be great.
So I know I mentioned earlier that I was going to ask some, after we've done the introduction, I was going to ask some targeted questions towards each of the panelists. But I still want you guys to go ahead and like raise your hand or interrupt at any point if you have a follow-up question that relates to the questions that I'm kind of asking. Because I'm basically just trying to get conversation started. So if you guys are interested in anything in particular, feel free to interject at any moment. But we will have time at the end for just open questions of any sort. Okay, so maybe we'll start the opposite order now. We'll start with Megan. So I have a few questions that I've kind of prepared. So one of the questions I was wondering is, are there any significant sources of frustration that you encounter on a regular basis in your job? And if so, what are they? And do you have any strategies for avoiding or addressing them?
That's a really good question. I think one of actually the things that I didn't realize before going into industry was one, the size of the data you're going to deal with is going to be much bigger than anything that you've had to deal with in academia or like in stuff before. And the other thing is sometimes there's a lot of, I know currently at my job now, there's a lot of red tape in getting access to the data. So I actually sit around and wait a lot. I'll put in a data request and then they won't let me touch production, so I have to wait a little bit, or like you have to figure out, there's a lot of actual planning that goes into, okay, what are we going to ask for? Is this reasonable? Is it going to break things if we try and query this? And actually having to do that kind of like back of the napkin math on, is this going to break everything that we've built if we actually pipe this in? It's something that we dealt with at Mobify. It's something that I've dealt with at multiple places. And so you just kind of assume that you're going to get a data set and you get to start running and modeling on it right away. And I've been at my current job for 8 months, and I think we've run like 3 models. The rest has been data processing, making sure that it's actually valid, making sure we're getting the data that we think we're getting. Is the event coming in the way that we think it's coming in, and being able to test that and make sure that when we do give a result, it's actually based on data that's solid and that isn't something that someone's going to question and be like, well, that doesn't make any sense because what I know of the data means that your result is wrong. So making sure that you be able to like talk to the people who are giving you the data, talk to the people who want the result from you, and being able to then model it properly is something that you don't think about. And then all of a sudden that's 90% of your job. Yeah.
So just as a follow-up, in the whole data processing stage, is there any particular like specific bottleneck areas that you think could be addressed and could move a lot faster than they do?
That really depends on the company that you're working for. The company I'm currently working for has a lot of privacy concerns. And so you have to get sign off from like 5 different managers before you can access someone's data. Because technically it's like device level data for a user, and like you need a background check, you need all of this stuff. And sometimes there's literally nothing you can do but wait for 2 months and hope that they give you the go ahead. Other times you just have to make sure that you have that relationship with the stakeholder so that they know when you're requesting something, you need to be like, I'm requesting this because I'm going to give you this result in the end, and that's going to make your life easier, so you're going to help me. So actually being able to build personal relationships and be able to demonstrate to the stakeholders that like what you're doing is actually going to be useful is a skill that I don't think you really get training for until you're thrown in the deep end and you have to explain why you need that data and like why something else won't work in order to give the result that you need to give. Yeah.
Awesome, thank you. One more question for you. It kind of sounds like you were getting towards this towards the end of your answer there. So I wanted to ask, are there any specific habits that you would suggest students begin developing to have successful industrial careers? And if so, what are they and why are they important?
Sure. There's probably lots, and I'm sure I'm not going to be give an exhaustive list. I'm sure the other panelists can probably add to this. But I'd say organizational skills are really important. Being able to like document what you're doing, write down what your thought process is, because I know something that I'm constantly working on is that you go back and you look at your code and you're like, why did I do it this way? Like, why did this make sense to me at the time? So making sure that you have the ability to document it and write it down, because if you need to go back to it later, it's definitely something that's good. Learning tools like Git, learning other languages, not just Python and R, but learning SQL, learning some other little bits and pieces, like being able to visualize the data, being able to do things like that. That's going to only help you to be able to have those things in your toolbox. And they're not necessarily things that you might get in your academic career. So the more you can broaden that, the better, and the more useful you're going to be going forward. And again, like, I'm going to just be probably that person on the panel today, being like, interpersonal skills are really important. And being able to ask questions and ask for help is invaluable. I know poor Boris back there has definitely been on the receiving end of a lot of really what I thought were dumb questions, but the more you ask and the more you collaborate, the better it is to be able to go forward. Yeah.
Awesome. Thank you. Yeah, maybe we'll just pass the microphone along and we'll go in that order. So, Zach, I had a question for you. I was wondering if you could describe, you've been at Amazon for a while now, you were saying. I was wondering if you could describe one of the more challenging problems/projects you've encountered while working at Amazon and what steps you took to resolve it.
Sure. So I'll stick with a more generic answer versus a specific one, because I don't know if we can discuss a lot of the specific
It's a problem,
things.
isn't it?
It is a problem, yeah. But you know, one of the things that I've learned over and over and over again in my career is that once you think you've solved a scaling problem, you haven't. So I can give you guys an example of of an all-nighter we had to pull. Was we were adding hosts to one of our fleets, and our fleet size was somewhere around 6,000 or 7,000 hosts at that point. So why not just add a couple of thousand more hosts to it? We were getting ready for a really big peak season. I think it was something like Prime Day or Black Friday or something like that. And basically, what ends up happening under the hood is that when you add hosts, they all talk to each other at a certain degree, or they are all communicating with each other. But there's only so many ports that are available. There's only so fast data can sync between your hosts. So we ended up adding a couple of thousand servers to our fleet, and what we realized was our caches were not able to keep up. And every hour on the hour, we had a job that was running that would sync all the cache, and we would see a massive spike in fault rate, and then off you go again. And then every hour it just kept getting bigger and bigger and bigger. And it was a reminder that we take scale for granted, and we just take being able to horizontally scale for granted. And there are scaling limits, and you really do have to think about that. And that's something that I've learned over and over again, and I don't know why I keep having to learn that, because it is one of those things that's very difficult to think ahead, because you assume your stuff just works and you extrapolate. But the only suggestion I would have here is that always be vigilant. If you're making a change, assume it's going to break something. Write really good tests, and think about all the bad things that can happen and protect yourself against it. So
Sandbox thing.
Sandbox, exactly. Yeah.
Okay, thank you. I did have a... Yeah, you can, for sure.
Yeah, that is such a great question. I'm going to echo what Megan actually said. Interpersonal skills are so important in the industry. You need to be able to speak and articulate your points very clearly. And coming from, and I'm sure Roger, you can attest to this, being at Google, is we're an extremely data-driven organization. So we don't make decisions based on anecdotes. We make decisions based on data, and every single thing is based on data. Sure, you can make hypothesis, but your hypothesis will generally start with some level of data, and then you can extrapolate from there. So, but to go back to Lillian's question about, what is it that we look for? Interpersonal skills are extremely important. I know it's going to sound a little cheesy, but your go-getter attitude is going to take you a very, very long way. A lot of the problems that we're solving today, there are no textbook solutions. I promise you, the problems that we're working on, in some of our industries, there are no textbook solutions. How do you synchronize data across 50,000 hosts? There are no, algorithms for that. How do you densely pack as much data into a disk as much as possible? There are no algorithms for that. So you are going to have to figure that out. And so what I look for at least, are folks that are able to think on their feet incredibly fast and take a challenge and dissect it and not get lost in the details, but figure out, how do we take small chunks out of that problem and not get lost in the forest. So.
Awesome. Thank you. And thank you for the question. It was a very good question. We surveyed the participants, and one of the questions we got back that I was meant to ask was, people wanted to know, is demonstrable knowledge and experience in data science, so like being able to show a GitHub repository that you have that shows work that you've done, is that sufficient for employers, or are there any particular certifications that one could acquire that employers would be looking for?
Do you want to grab this one? I think you guys are probably in the field.
No, I think this is your question.
Okay, all right. So yes, market yourself. Absolutely market yourself. We do absolutely take a look at your GitHub repositories. We take a look at any kind of open source work you've done. If it's on any other forum, those things are incredibly helpful. So then, the TLDR is yes.
Okay.
Yeah.
I have a question for you.
Yeah.
Since we're talking about how do you get a job?
Sure.
Do you do these exams where you have prospective employees do little tests for you?
Yeah.
And if so, what do you learn from them?
Yeah, that's, again, really good question. And we've actually got a couple of teams, folk with data scientists behind those, to analyze those results. So Amazon is heavily into experimenting with our hiring process. So the traditional hiring process is you get a phone screen, you talk to one of our engineers, or if you're a product manager, or if you're a manager, and so on, you speak to somebody over the phone. They say, yep, this person's good enough to bring on site. They'll meet our bar. You come on site, you meet with about 5 people. I'm sure you guys have heard about the Amazon interview process, and off you go. So that's the traditional process. Most companies follow that. We have started experimenting with almost, this is going to sound terrible, but it's not, almost no human interaction at all, where we will give you behavioral questions, you'll answer them, we'll have algorithms that are running on your responses, we'll pick out specific words and so on, they'll assign some sort of a grade to it, then you... It absolutely, yeah, go figure. And then once you pass that, you can move on to the technical questions and so on. And analyzing your code is super simple. We've done it for years now. So we do experiments like that as well. So that was one of the more unique ones we have done, where we have hired folks without even meeting them. So that was an interesting one. I was as a manager, my group is fairly large. I was skeptical of that, but it works. I mean, you're always going to have that negative ratio of folks that are we haven't really fine-tuned the algorithms for them yet, but you learn, and that's where machine learning comes in. Is you learn, you feed the data back in, and you get better at it.
Just from the other side of that, I've been on both sides, I guess, and I know what we did here at Mobify. We almost the opposite, where it's a lot of interpersonal interaction, not necessarily like an algorithm, because a lot of what we looked at was we'd give you a problem, and we want to see how you think about it, and we want to see how you explain how you think about it, and how you would work with the team. And I know at Mobify, actually, what they do is they'll actually get you to come in and work with the team for half a day to make sure that it's a good mesh, and that you can explain yourself, and that like you're able to communicate, you're able to do things like that. I mean, you do still have to pass a certain level of coding proficiency and things like that, but definitely when it comes to being able to mesh, and especially with a smaller team, you want to be able to make sure that there's both. You can explain what you're doing, and we can look at how you're thinking and how you're tackling the problem, and if what you're doing seems good, and you can explain it, and you can explain to us why you're doing what you're doing, then that's something that's really important to us. Yeah.
Thank you. To echo what Megan was saying, fundamentals are super important. Do not ever skip fundamentals. And that's ultimately what we look for in our interviews is we'll give you a coding challenge or whatever it is. We're not looking for the most complex data structure you can think of. We are looking to make sure that you know what an array is. You know how to sort the data. You know that this is the right type of sorting. This is where this is the sort that you would apply to this type of problem versus this type of problem. And those things are extremely important. We don't want our engineers to reinvent the wheel. We want our engineers to enhance the wheel. So fundamentals are just so important.
Awesome, thank you. Maybe we could pass it off to Roger and talk about some entrepreneurship questions.
I think the most important thing that will come out of today's discussion, because we're all going to say it, I can see it already, is that being to relate to other people is incredibly, incredibly important. So don't underestimate the unique skills that you all have, because you have a fantastic education. But being able to explain the nature of your education and what you do to other people and just get along with them is something that I know that I can't teach someone that I work with. Companies know that this is the fundamental thing. You can teach someone how to program, believe it or not. It's not desirable to have to teach everyone who comes in the door new programming skills all the time, and that be the only thing that you teach them. But it's impossible to change a person's personality. So having a really good rapport, and I work very closely with people one-on-one because I'm a small company, and so having that one-on-one rapport with people, that matters to me more than just about anything else. And then we start talking about, do you know your fundamentals, and then do you know how to, express those fundamentals in a computer program and so forth. But interpersonal skills and certainly being able to explain with confidence, can you go to a cocktail party and have an intelligent conversation with someone, and will they be excited about the thing that you're working on? And if the answer is yes, then you're really already a lot of the way there.
Thank you. This is kind of moving in a little bit of a different direction. I was wondering if you could tell us about some of when you decided to leave Google and come back to Vancouver to start Midvale. I was wondering if you could tell us some of the starting steps that you took when creating the consultancy business.
Yeah, the first thing I did was I made sure that I had a job. In the following sense, I made sure that I had at least one person, in fact I had two at that time, that would hire me to just do something. I had a tiny bit of money coming in the door, and these were from people. I met one guy on the bus, and I met the other guy actually at an ISPW, an industrial math workshop at UBC. And these were both relationships that I'd cultured towards the end of my PhD, so I had something that I could do, someone that would pay me. So beyond that, I had a brother, as I say, who had spent by then 15 years running his own consulting business. And we went on a long walk, and we talked about nothing technical whatsoever. What we talked about was you need to be able to explain to people, what you're working on, what you're able to do for them in plain language. Even though they will know some math and they'll be excited about math, you're talking to technical people usually when you're doing a technical job. They have to explain it to someone else too. And so giving them some tool sets for doing that is really important. And then there's some things like, don't piss your clients off. Don't explain things in a way that makes them feel like they're stupid. It's most likely that they're not stupid and they're just struggling to understand you. And I mean, I'm sort of saying this in a tongue-in-cheek way, but when you're surrounded by this group of people, we all know a lot. And if I try to talk to Brian and we're talking about matrices and he's sort of like not able to understand what a matrix is, then I'll just get upset. But that's obviously not something you have to curb all of those things and say, well, oh right, well, you obviously really want to understand this, and so let's talk about this in a completely different way. And I don't know, it's that kind of practice that was absolutely critical. Yeah.
So after starting the company, did you when it came to growing the company, did you focus on one specific area, or did you try to move out into a bunch of?
No, I am not the person to talk to about how to operate a quickly growing business.
Okay.
Not at all. The way that I've managed to keep doing what I'm doing is through continuing to meet new people. So the saying is, it's easier to get a job when you have a job. And it's very true. You're not stressed about getting the next job because you do have a job. And you have a little bit of something for the other person across the table from you to say, oh, well, other people are hiring this person, so maybe I should before they get snapped up. So it's kind of keeping that chain going. I've already forgotten the question. What was the question?
It was about where you went with Midvale. Did you expand into a bunch of different areas, or did you just kind of?
Yeah, so no. That would mean specializing so much. I really, I focused more on the people that I met, and I solved the problems that those people had. And so that meant it's exciting because you always get to learn a whole bunch of new things, and I know now a plethora of programming languages, a bunch of different frameworks, as well as knowing a bunch of new mathematics. I think I knew no probability when I graduated. I wouldn't advise this for anyone. And so, you just gradually have to pick these things up. So there was no specialization except for adjusting what I could do, because I know that I have a capacity to learn things very quickly, as do all of you, and leveraging that and your ability to talk to people rather than saying, I am an expert in matrix multiplication or whatever it may be. I am an expert in statistics is actually a really common one, and it's not necessary. It's necessary to say I'm an expert in understanding your problem.
So would there be any way for you to say who an idea of who your typical client would be for those type of a problem, or could
yeah.
just so broad?
My typical clients, in every single case, I've met someone in the company who is a person of influence. So I've met a CTO or a senior manager, and it's really a case, I guess, if I look back, I'm leveraging their influence in the company rather than for me having to move an entire corporation in order to get myself involved. And I think it's the individuals that you meet that make certainly what I do possible.
So you have to have some level of influence on them in order for them to use that influence.
Yeah, and the influence comes, I hope that I do. I hope I come by it honestly, which is to have that conversation with them. And, I've been, as I say, I think I've been fairly fortunate. Out of, every 2 people, one of them will turn into a client that I do some work for, which is pretty good. Like, not everyone spends, $20,000 or $200,000 on a project, but even if I have a project that's, a $2,000 project, then I consider that a success because that person was happy and I have a new relationship.
Awesome. Thank you very much. Maybe we'll pass it over to Bernard. So I saw you were excited about one of the questions that I had listed for you, so I'm going to start with it.
Okay.
Can you describe your project with Embark at SFU?
So that project was about looking at the data from TransLink. So at the time, I was taking the bus a lot, and this particular and I was really frustrated with how the buses were late all the time. I'm sure if you take TransLink a lot, you would have the same. So I was looking at their prediction, and I was looking at, while this saying that should have been here 5 minutes ago, or 5 minutes from now, is not here for 5 minutes. So I got really frustrated, and so I wanted to solve a problem. And so I solved the problem I tried to solve the problem for myself by grabbing the data from their API. They have an open API. So you can just, collect the data and keep collecting the data, and I start doing data science work on it. So I started, with the, just basic statistics, saying averages, how long does it take, is it actually on time? And then I try to do some classification on it. So you guys learn classification, I think, on Tuesday. Mm-hmm. So I try some basic classification and say, is this going to be, is this bus during this day during that time. Is it going to be on time or not on time? That was all I wanted to do because it was getting me frustrated. And I actually learned a lot from it. I learned, so eventually I took this project to TransLink, and one of the project managers said, well, do you want to do a lunch and learn? And so,
Can I just ask a question?
yeah.
How did you meet this person?
Oh, I just randomly emailed him. Like, that was not the person that I started emailing. It's just somehow I got passed along the way. Actually, what I really wanted to do was get to their internal data set, but so I actually went all the way to signing the NDA and stuff like that, and they never released it to me. So I think I could have done a lot better because there is a resolution problem with the data, with the API. The resolution is only 1.5 minutes. So 1.5 minutes is a long time between where the buses will be. Anyway, I noticed like there were some problems with what they were doing with the buses, and so I said, well, if I was a data scientist, this is what I would do and change how you operate your buses, where you put it was specifically into where they would put the bus stops. Like if you notice where they put the bus stops, they always put it on a corner of the street, and the bus will stop twice. You might stop for the passengers, and you're very likely to stop again for the red light. So you're very likely to cause the buses to basically sit there for 5 minutes, something like that. And I said, this will improve your flow. And they actually had a very good reason. So this is where domain knowledge comes in. And they said, well, the reason we put it in the corner is because more people can catch the bus. If you put it in the middle of the street, someone would try to catch the bus by just crossing the street in an unsafe manner. So we put it on the corner to keep things safe. So I was like, okay, makes sense, safety. So safety first, right? So, but that project, I was very excited about it because it's a project that anybody can do. Like anybody can just take an open API, collect the data, and make an interesting project out of it. And you can try to talk to the manager and say, this is what I have done, look, And yeah, it was a fun project to do, actually.
So did you get to anywhere, like any final methods that you were using to do any kind of prediction with that project? Or where did the project end off at the very end?
There's still an AWS machine running collecting data.
Oh, okay.
I want to go back to it at some point because I would just want to collect a bigger data set.
I see.
And just for the fun of it,
Yeah.
I actually want to make some real-time dashboard for like myself again because I get frustrated with the buses here. Anyway,
Awesome.
yeah. So actually, but what I want to say though, that particular project, like in relation to you guys, would be that every time I've gone to an interview, people look at that and say, "What did you do there?" And it wasn't actually like it wasn't an accident that I picked something that people can relate to. And you should start with a problem that you want to solve, because if you start with a problem that you want to solve, people can relate to that. And then all of a sudden that you can show off your skills. You can show off that, oh, I know how to connect to APIs. I know how to collect data. I know how to clean the data. And actually cleaning data is a huge problem because I had buses that were in the middle of the Burrard Inlet. So that can't possibly happen. Cleaning data, how to actually apply machine learning and do all those things. So having a project that can show off your skills and show off your presentation skills is fantastic, and that's why I was excited about it. I'm not really involved with this particular group, but there is a group called Data for Good Vancouver, and they are on Slack. You can probably find them on somewhere on the web. They do. I don't really know too much about them because I don't go on that Slack channel that often. However, you should check it out to see if there's something interests you and start doing things that way.
Sorry, what was it?
Data for Good.
Okay.
There's a Toronto chapter that's been around for a couple of years, and the Vancouver one just started a couple months ago.
Okay.
So
Awesome. Thank you. So maybe we'll go to Lillian, and then we'll end with opening it up to the floor in case any of you guys have questions. Okay, Lillian. So did you just start? How long have you been working at Amazon?
This is my 5th month in Amazon,
Okay.
and before that I worked in another data company in Vancouver.
Okay. I asked that because I wanted to ask you if you could describe the learning curve you've experienced so far in your first few months at Amazon.
Oh, very steep. So getting hired doesn't mean that you can do everything on your job, because there's always something that you don't know. And I agree with some of the panelists' comments here that learning things, learning from mistakes, learning in a systematic way, document the stuff that you did is very important. And also communicating your thoughts with other members of the team who might not have a technical background, it's extremely important, because let's say a VP comes in and say, hey, how's your project going? You're not going to show him or her all the statistics, like 500 numbers, like, oh, pick it for yourself. So you have to form your narrative based on the data, but sometimes within a corporate, everyone has the different interests. They want to drive their own initiative. Someone else wants to steer this in another direction. Sometimes these directions don't necessarily align. So how do you use your data and leverage that, and explain to them, okay, this is the best explanation, or this is the best solution that I propose to your solution, because to your problem, because in the long run, people are going to say, hey, the solution that this scientist proposed actually works, or, oh no, they're horrible, I implemented it, and 2 months later I lost $1 million. So your reputation will actually grow within the company, and building trust is actually a very essential step to building a career in the long run, not just for this job, because you can have a job for a year, and then at the end of the day, if no one is happy about you, you will just get stuck here or even get fired. The reality is that people do get fired. I have experienced it, not only in this company, but in other companies. So getting yourself in is first step, but maintaining your job and hopefully keeping your job and advancing in your career is something to think about even when on day one. Yeah.
I think you were kind of already getting into this, but one thing I would like to ask you explicitly was, is there any specific advice you'd offer to students to help them make that transition into industry, particularly with respect to like a larger company like Amazon?
You read my mind. That was something I actually want to speak about. So I would say in an interview, I don't know how it is from the employer's side of it, because I haven't done any hiring in Amazon yet. But I feel like that should be something you should be good at. People feel like, why should I hire you? Just keep asking yourself this question. Why should I hire you? Why should I be hired? Let's say you're a mathematician. There are thousands, tens of thousands of mathematicians graduating every year. Why should I hire you? What makes yourself special? Oh, okay, yeah, okay. Yeah, that's true. Maybe let's say thousands, at least in Vancouver, maybe hundreds, right? So why should I hire you? Because we are essentially not competing only amongst mathematicians, unlike postdoc positions. We are competing with physicists, our close cousins in academia, but also people with CS degrees who have had more experience than we have more projects than we have done. When I applied for jobs, the number of projects that I've done was 0. Let's say if someone asked Bernard, he's quite experienced, he actually stands out, he has done something very interesting, something that people can relate to. But let's say if someone throws that question at me, what can I say? I mean, I just got out from a postdoc. What project did you do? Can you tell us something about it? I did something on differential equations, and details cannot be understood by anyone without a PhD analysis. That's not the way to go in an interview. So yeah, I think one of the observations that I made through talking with my friends is that a lot of people wanted to transition into the industry from the academia, but the reason that it hasn't happened was mostly they didn't prepare themselves well for an interview. For example, they walk into the interview room, like Zach mentioned, the employers really expect you to know the fundamentals well. Not like you can say, oh, I know Python, but then they say, oh, how is a Python list? Is it like an array? Is it a linked list? And things like that, right? How is the structure? How is the structure? How is it implemented, right? So you're supposed to know these things like very well. Not just like, oh yeah, I can Python, I can code in Python, but when you're asked like, oh, how do you implement certain searches? Like, oh, I've not done it before, or I've not even thought about it. that's something not acceptable, because you'll be out right away. In good companies, if you can't answer fundamentals like that, you're out. Then the consequence of that is what? How many companies are there in Vancouver? Yeah, there are many, but if you want good work, good pay, interesting people, right? So everyone wants a good job, right? And then if you bomb this chance, many companies will bar you from reapplying within like 6 months, 8 months to a year. So another consequence of that I want to bring up to your attention is that you might end up in a job that requires less skills than you have. And then what happens is that your pay will start from a very low start in your career. And think about how much time you have wasted to climb from this level to the level that you actually deserve, given the education that you've gone through and the effort that you've put in to prepare yourself as a mathematician or statistician, right? It's hard. Think about it. If you enter at a job with 40K per year, it is extremely difficult in the negotiation process to bring it to 100. Every recruiter that I've spoken with will ask you, like, oh, what is the pay range, pay bracket of your previous job? If you start with 40, a 60 would be a big increase. Can you bring it to 100? Possibly, extremely hard. So it's not a problem that it bugs you right now. If you have a poor start, if you don't prepare yourself, you are putting yourself in a very, very big disadvantage, especially for people who spend years in grad school and as a postdoc. You don't have a lot of time to waste anymore. I know that seems like a warning, a dire prospect, but it is true. When you're 30, you start with 40. How many years do you want to take until you say have enough money to retire? Just a simple question. Yeah.
Thank you. And maybe one more question before we open it up to everyone to ask questions. So one thing I wanted to ask you was, what was the group dynamic and work environment like with the machine learning team at Splunk, and how was it? Was there any notable differences between the work cultures at Splunk and Amazon?
Yes, there. I think both companies are great to work with, great people, and there's a lot of room for us to learn. So I just want to talk about my more recent experience, because I've been with Amazon for 4 to 5 months already. Everyone expects you to work very hard. So don't expect to have 3 months of vacation in the summer. When you talk about summer vacations, people are going to say like, what? We have 3 weeks of vacation per year. So in case you're thinking about industry, this is the reality that you have to face, that you will have 3 weeks. 1, 2, 3. 3 doesn't multiply by 7, but multiply by 5. You have 15 days off per year. Reality. Reality number 2 is that your paycheck will probably expand by 1 0, so not bad. One more digit in the back, not bad. When you compare it with your graduate student stipend versus working in industry, it's a logarithmic increase. So that's something to be happy about. The stress level, stress level is different. In the industry, you have more stress from deadlines, because let's say recently our director came to visit us, our SVP wanted a report from us. We have to do it. Okay, if you're in the academia, you're only responsible for your own stuff, but in industry, you actually are responsible for completing your own stuff and cleaning up the mess that someone else created, someone else in your team, someone else not in your team. So I'm not telling you that everything is rosy and everything is perfect in the industry, but the good thing about the industry I don't want to scare you. The good thing about the industry is it has many interesting problems. It might not be the same as what you have been doing, all theoretical, you can speak to 5 people in the world. No. So you can speak to, and then there's a lot of applications you see real-time impact. You're making some positive changes to the world sometimes. And the other thing is you can still go to conferences. Let's say within Amazon, I went to machine learning conferences. There are a lot of extremely intelligent people that you can talk to that I learned a lot from, because their experience in the industry and the way they systematically learned things on the job actually were very important to me, because there were many aspects of the problems of problem solving that I did not think of in the past. And then by talking to, software development managers like Zach, I was like, oh yeah, if I have to plan a project, there are so many things that I didn't think about, and I actually have to communicate, like communicating with different stakeholders, how to persuade people to, grant access, like Megan just mentioned, or just to use the server, and things like that. These things take time, and having good skills with people would keep your life a lot easier and stress level a lot lower.
Awesome, thank you. Before we open up the floor to the audience, do you guys want to say anything else? Did anyone have anything else that they wanted to say that they didn't get a chance to?
No. Yeah, I have a list. Get ready. No, I think Ling made a really good point about industry, and the one thing that I can say, having now worked at companies of various different sizes, I've worked kind of at Mobify as more of a startup when I started, and a couple of kind of bigger corporations, is that does vary a little bit depending on what you want. There are definitely different sizes and experiences of industry, because if you're going to start in at a startup, you're going to get to do, say, a lot of different things, and you're going to be responsible for a lot of stuff, and you're going to be thrown in off the deep end and have to be the only one who can answer a certain question, which can be really great and can be great for building skills and being able to learn and do lots of different things. Whereas at a bigger company, there are maybe more people to learn from, which is also very useful. But again, it comes with some of the red tape and some of that other stuff that comes with it. But that's another thing to keep in mind when you're thinking about industry, is not just what industry do I want to be in, but like what size of company, and what kind of product do I want to be working on? Do I want to be working on the product side, or do I want to be working on, say, the marketing side? Because there's definitely a lot of data that goes into the marketing and sales and things like that. And those definitely have kind of different experiences for you as a data person, and there's lots of opportunities there, which is great. Yeah.
Thank you.
Actually, I have a question. So I have attended and failed in coding interviews, apparently. So from a manager's point of view, what do you think are the most common mistakes that candidates make? So some of these people could be pretty smart, but why did they fail the interview from your perspective?
I don't know if there's a generic answer, but maybe I'll take a step back. Whatever you do now, and whatever you go back and touch tomorrow, any kind of algorithms you're going to write, any kind of code you're going to write, this is just some food for thought. How often do you ask yourself, why does it work the way it does? So, for example, again, just some food for thought. How many of you guys know about pipelining on a motherboard? Right? Pipelining on a motherboard, right? Well, that's kind of how a computer works, right? That's the underlying reason why your queries run fast or your queries run slow, and how much slice of the CPU you're going to get for your query. Ask those questions. And the folks that don't generally don't do well in our interviews are the folks that have not spent the time asking, why does stuff work the way it does, right? We want to see curiosity. So, if I were to interview Bernard, he would absolutely get that job, by the way. Learn. Maybe. Hey, I have your email. Those things matter, and that's kind of what we look for, is are folks that are, everybody's passionate about something. Show us that you're passionate about it, and demonstrate your deep knowledge. I will generally ask, and my questions are fairly simple. It's, here's a string, do something with it. A lot of people fail that simple question. And the reason why they fail it is because they're not able to explain to me why they approached the problem the way they approached it. A lot of folks don't solve that problem, but they're able to at least provide that pseudocode and able to explain, what, I would use a hash map for this problem because this is, these are the X, Y, and Z reasons I'd use a hash map. Or I would use an array, I would use a linked list, I'd use, whatever abstract data structure I picked. And what we look for is not just surface level information, but somebody that's spent that time analyzing and asking why. Why does stuff work the way it does?
Awesome. Thank you. So maybe now we'll ask the audience if you guys have any questions that you would like to ask anyone. You can either ask general questions for any of the panelists, or you can ask a panelist a specific question. Yes?
So, we as graduate students typically do some research and then we write a paper. And my question is, what type of work are we expected to do when we go from this? I know it's very general, but how do you present your results? Do you make a code that gets put into a pipeline, or you analyze data and you show the statistical results?
I know for me, I do a combination of both of those things. So depending on the problem that we were given, a lot of times I don't know if this is true for everyone, but like my companies have been working on the agile system, so I'll get a ticket that'll say investigate X or whatever it is. And most of the times that ticket will have some sort of acceptance criteria at the end that will say, like, at the end we want to be able to answer this question, or we need a presentation that we're going to present to this stakeholder and they need to know how to make a decision based on that data. And so the end result may be, hey, we can't answer this question, we don't know what's happening, and you have to be able to write that up and present that to whoever it is that's asking you. Or you maybe make a presentation. I know here at Mobify we do a lot of things where you'll have an all hands and you have to present it to the company and say, here, we did this investigation, here's what we found, here's what this means for decision making, and like be able to talk to one of our salespeople and say, you need to know this, and here's the information that you need. Now you can go and talk to a prospect and tell them about this, and that will be great. Or it will be, code that then goes in, integrates with some of the things that the other engineers are building, and they take that, and you have to be able to then kind of act as the go-between between like the project manager who's saying, okay, I need to answer this question, you need to pass this on, and the engineer saying like, okay, I need code, but I need it working in this way, and so be able to write something that can then answer the question and like solve the problem that you were given, but also have it be solid enough that an engineer can take it and be like, okay, I can put this in production and it's not going to break everything, and they're not going to hate you because you've written something that doesn't work and now everything is broken. So yeah. Anyone else?
I'll add something to it. So very much what I produce for my clients is something that's standalone. So a really concrete example is they'll get an IPython notebook, and it has a bunch of text math at the very end. It has some English words at the very beginning. It has a piece of code in it that is, as far as it would happen to be in Python, but that's good enough to be pseudocode to an engineer who will implement it in the system that they're finally going to put my result in. And that's been a very common deliverable. Another deliverable is a command line tool or a tool that they can run for years that also has your email and phone number. I'd like to think of it as future business, yeah. But
Your hourly rate?
and my that's right. You got it. But no, I can't put that in there because that changes from time to time. That's right. It's inflation. Inflation. No, you do have to be contactable if you provide something to a client. Absolutely. The phone number sends mixed signals because I don't always answer my phone if I'm on vacation, but people need help. And it's rarely a paper. It's rarely a paper like a publication. That would be very, very rare. The closest thing that I'd come to is a presentation to basically say, answer a yes/no question. Yes, you can do this in your company. No, I don't think you can do this in your company. And then there's addendum. This is how much it's going to cost if you want to actually implement this. So these things, for me, are very different than some of the things. If you work full-time in another company, then you do a lot more of that iteration and follow-up. And as a consultant, it's bittersweet. It's like sending your baby out into the world, and you might never see it again. And it feels very different. You're really letting go of something. It's not research that you're going to maybe even continue. You'll have that base knowledge that you collected about statistics or whatever background that you didn't know before you started. And then that's what you kind of retain. And the best you can hope for at that point is that you've also retained the relationship with that client, and that they tell someone else about you as well.
Okay, thank you. Did anyone else have a question? Aaron?
Out of curiosity, do you charge an hourly rate, or do you sometimes have to charge like a lump sum upfront? If so, how do you estimate your time? So I do estimate time, and I do have an hourly rate in mind whenever I quote a job, but I try to hide my hourly rate from the client. And there's a concrete reason for this is, from their perspective, they want a deliverable. We talk about what that deliverable is going to be. It's going to be something that's pretty well laid out. And they need to know that they're exchanging a fixed amount of money for that deliverable. Giving them some certainty is really, really helpful for them. It means that I assume a bunch of risk when I do that, because if I misquote a job, then I just end up spending tons and tons of time on something that earns very little money. And that's challenging, and that's something I've gotten a lot better at over the last decade, necessarily. Because you haven't seen the problem before. Certain parts of engineering problems, engineering solutions, you do know the answers to. You do know how long it's going to take for you to code up an interface to a database. You do know that. You do know how long it's going to take to set up a VM in order to get your clients to be able to run the example that you've given them. So those kinds of things you do know. The long tail, I do my best to try and estimate. And the thing that's really awesome to be able to do for a client is to say, you know, this job was $10,000, and sorry, I misquoted it, it's only going to be $6,000. And that just like brings in, oh, I have $4,000 available now. What else do you want to do? It's really difficult in the client if you constantly overquote because they reserve resources for your project, and they won't, and they will stop trusting your quotes, basically. But that's what I've started to do more and more, is basically respect my own time and have this understanding that the client does value what I'm doing. So when I charge them for my time, which could be a lot of time, they are not going to be upset about that, and they do really value that. So clients don't mind spending money as long as they get value, and I think that's the main lesson over the last decade.
So I can add a little bit to that, yeah, please. If you don't mind. So to add a little bit to that, learn more about the business side before you even as a hobby, even if you're just reading some books. One of the best books that I've read out there, it's called Lean Startup. It's by Eric Ries, and it talks about a lot of fundamentals about just running your own business. A lot of things that Roger spoke about. I've been a consultant for 5 years, and I've gone through lots of projects where it's being charged hourly. And then we did fixed bid, which basically means it doesn't matter how long it's going to take, you're going to finish that work. And you work night and day to get it done to make sure you retain that customer and they become a reference for you. Those things are extremely important. A lot of the times, the money is just not even important, because if that customer is a reference for you, the business will just come in, because other customers will say, oh, you've done work for that financial institution? Of course, doors open, right? So learn about what net margins are. Learn about what contribution margins are. I've got a degree in computer science. They don't teach you those things in school, but those are incredibly important if you're going to start your own business. I would highly recommend Lean Startup and just understanding how to read a P&L, which is a profit and loss statement. There are tons of, just Google it, basically. And it's eye-opening how many things you need to know before you start your own business. But it's all good things. And the more you know, the less surprises you're going to have, to be honest.
Awesome, thanks. Yeah?
Is it true, or is it an urban myth that master's degree or industry job master's degree is more competitive than PhDs, postdoc?
So I don't know if I have here's what I can tell you is, I think it depends on the field, to be perfectly honest with you. It depends on what you've specialized in and what kind of demand you're going to create based on the knowledge that you've gained. it's definitely going to help you get your foot in the door, right? Beyond that, it's all fundamentals, and it's what you deliver and what you contribute. I know it sounds kind of silly. It's not, I promise you. What you're learning today are the fundamentals, and you know, your degrees from whatever university is going to help you simply get your foot through the door.
Yeah.
Beyond that, it's what you deliver. I don't know if I burst your bubble, but.
Yeah, I mean, I can say that when I've been interviewing, like, we kind of look at the degree, but once you've got some work experience, what we're going to be asking you questions about are going to be that work experience and a problem that you've solved and how you solved it. And that's still going to be the question that we ask when you come out of academia. Like, you're going to say, okay, in your PhD, like, what kind of data did you deal with? How did you, what problems did you have with it? How did you tackle them? What was your thought process? And I mean, that's what you're going to be asked about again once you've got some work experience. I don't think I've ever looked at a resume and been like, oh, they don't have a PhD, like, we can't talk to them. Like, that's never been something that has gone through our mind. It's been more, can we talk to the person? Can they communicate what they worked on, why it was interesting, how they solved it, and how they would go forward with the problem that we gave them as a test. Yeah.
I would be interested in knowing how this question would relate to more of like the algorithmic-based hiring. So the automated data-driven hiring process, how would someone's education, whether it's master's or PhD, be affected by that machine learning model that takes into account all that information?
Yeah, I don't think we know yet. It's still super early days.
There's a wait.
Yeah, that's exact. It's absolutely going to help you get your foot through the door. There is no doubt about that. What I can also tell you is don't expect your PhD or your master's or any of your degrees, regardless of what university it's from, to pay off day one. These things pay off down the line, right? We have folks that are all junior engineers graduating from Cornell, Harvard, Princeton, Stanford. They all sit in the same bullpen. They're all coding the same product. It's what you do with the knowledge that you've gained is what's going to get you ahead. But you know, I also didn't want to discourage folks from pursuing PhDs and masters, because those are super important, and we do have very specialized roles where those types of knowledge, that type of knowledge is required.
I think I interpret your question as basically asking, should I do a PhD or get a job, right? That's how I interpret your question. I can tell you a personal story. The same summer, in fact, I went down to do my postdoc, is one of my buddy dropped off the PhD program. And you know, he spent 3 years like trying to get the skills that we talked about to get to the job. And when he finally got the skills, he didn't have a PhD, but he spent the 3 years learning how to do programming, learning how to be a quant, and he got a job with Goldman Sachs, and his starting salary is way up there. So he didn't do a PhD, but he went and got the skills. So I think, you know, the PhD isn't going to do it for yourself. Do it for other reasons other than money. Like no one is ever going to read about, you know, symmetric bifurcation ever. Okay, but it was fun. I enjoy the papers that I publish. Do it for that reason. Otherwise, you're better off doing what my buddy did, which is, you know, get the skills you need for the industry, and yeah.
I want to add to that. Those years are not wasted. I absolutely don't and did not, and I think will not regret getting my PhD. Those are the best years of my life. I think one of the best, I hope, at least, or best years of my life. And that's where I met a lot of my good friends and also future connections. I mean, job-wise connections. That, you know, when I have a question about, you know, machine learning, the people that most often I turn to are, other than, you know, some colleagues at work, are people that I actually knew from my grad school years. I would ask them, like, I just sent an email to a friend asking a few days ago, oh, what is a good book for deep learning? Should I start from chapter 7? And then he said, too many examples there, go to chapter 9. I mean, these things save you a lot of time, save you a lot of hours banging your head against the wall looking for the right reference. And of course, when you look for a job, sometimes knowing someone who works for the company will actually help, because you can ask them like, oh, how is it working in there? I saw this New York Times article about one company who's traded on NASDAQ, but they said bad things about it. Is that true? Is that exaggeration? These are important things, because once you land yourself a job in a company, you don't want to switch, you don't want to hop once every 3 months, right? So knowing what you're getting into is important, because in the end, even if the company is bad, if you keep hopping around, it looks bad on you. You are the person who made the wrong decision to join several bad companies, and people are going to ask, like, if I hire you, are you going to leave in 3 months, right? So these are things to think about.
If you want to hop around between different jobs, become a consultant. Maintain relationships, but then you really can do 3-month projects.
Yep.
How do you deal with uncertainty in the sense that you have to, for instance, a project manager on the other side, and they ask you for a specific question and you understand it quite well, so that's not the issue, but you're not sure how well you can deliver that. How do you deal with your uncertainty and communicate it well so there's like no mismatch in expectations in the end?
I did this today. I think technically, I have a technical solution for this, which is kind of nice to once in a while have a technical solution, is to distill their ask, to distill their question down to the simplest possible thing that you could solve. So we all make models for a living. This is a lot of what we do. Find the simplest possible model of their problem, something that you can solve, just about in an afternoon, that kind of example. And you can put them on the hook for an afternoon and say, I don't know how hard this is, I need to go away and find out. And that's a better answer than guessing by a lot. And then you come back with something that's data-driven and say, okay, well, now I have some information about how long this is really going to take, and we can talk further about planning the project. That's been successful over and over and over again. And of course, fundamental to that is communicating with the person who's asked you to do something.
How did you get the data where you had, like, in order to solve the simplest question, you need the data in order to, like, work on that?
Sometimes you make the data up, as in you might actually run you might just run a random number generator to make some example data. For every problem, there's no simplest model for every problem, but there is a simple model that you can solve in a small amount of time. And then you get to have a discussion with the person who's asked you, how simple is this model? Is it too simple? Is it capturing everything we need? And then you're not engaged in basically a one-way ask where someone asks you something, you have to give it to them. You're engaged in a conversation. And that's a whole lot less risky for them and way more enjoyable for you.
I would say sometimes you have to take a look at the data that you have available. And like you said, you'd go and take a look. And sometimes the answer is actually no. Sometimes you have to be able to say no and say, I don't think with the information that you have, we can actually do this. And being able to do that in a diplomatic way is also something that's hard to learn, but it's because you want to be able to solve everything. You want to be able to run a model and have an answer, but sometimes there isn't one, and sometimes you have to go back. And I mean, a lot of my job sometimes is to go back and say, hey, we're missing these 5 different data points. If we want to answer this question and that's important to you, we need to figure out a way how to collect them. We need to figure out a way how to store it, and then we'll do it. And sometimes that's better than just, no, we're never doing this. It's never going to happen. And yeah, sometimes you just have to be able to say no when.
Knowing SQL is very important, at least for my current role as applied scientist in Amazon. So we have a huge amount of data, but if you have to rely on the software engineers to help you get data every time, they're going to hate you very soon. Like, you don't want to antagonize all the engineers on your team. So in my team, there are about 12 people, I think 12 to 13 people. And I'm the only applied scientist on the team. So which means, good thing is that I'm the only person on the team who does not have to go on call, which means that I don't have to, let's say, some of the weekends, I have to pick up phone calls at 2 a.m. No, a.m. It's not a mistake, a.m. Because I have to fix a system that crashed. Like, I don't have to do that. I'm the only person on the team with that advantage. But the other thing is that if you know the skills like SQL and database pretty well, and like Zach mentioned, like how things work, you can figure things out by yourself without too much help from your engineers. They would really appreciate it. Because you can think like, yeah, I'll ask questions, but if you have to ask a question every single step that you do, and without knowing the basics, without knowing the fundamentals, the curve will be too steep for you to deal with, even if you try very, very hard. Because on top of the learning of dealing with the learning curve, you still have deliverables that are expected from you, and that's only 24 hours a day. So I would say if you have time outside of Python, learn SQL is important.
I can answer it from the other side a little bit. So being the stakeholder of the person who's going to get that data, what's really important for me to see is what are the assumptions that the team is making. So what you want to do is when you have a tremendous amount of ambiguity is you have to develop your theories and your assumptions, and you have to present it. And then what you want to do is methodically build experiments and tests that are going to either prove or disprove your assumptions, right? And that's ultimately what I want to see to make sure that my teams are working as effectively as possible and we're driving towards the resolution. And to echo what these guys were saying is, look, a lot of the times we're going to have inconclusive data, and it's okay to have that, but you have to develop your assumptions up front and then figure out how you're going to validate them. The other, on the flip side here, you were asking a question earlier about, how do you communicate, what's important about it. One of the courses I took in university was called business communication, and when I was going through that course, it was one of the silliest courses, I thought, to be perfectly honest with you. And in that course, I still remember I learned the difference between THERE and THEIR, right? There and there. It's paying off now, 10 years later. So when I email, when I receive emails or when I'm sending off an email, making sure that email is polished, and I'm sure this goes for you too, your customers are basically, you don't want to send a sloppy email off to your customers, and that's exactly how I will review a doc when I'm seeing grammar mistakes here, non-capitalized letters here and there, and so on. Your data will lose credibility. So invest in learning how to communicate your ideas in a written form and using the right grammar. So
if your grammar's bad, what's your code going to look like?
That's exactly it. Yeah.